It could very well be in like 10 years that a large portion of the world economy may be run by agents. Just not agents of the, not even personal agents or the agents of the collective, just fully autonomous, fully sovereign agents. Crazy thesis, but I can't see why it won't be true. So it's a disturbing but crazy thesis.
Hey guys, welcome to another episode of Qualitative. I think today is the episode till date. I think the man for which this thing exists, there is nothing to be hidden out of that. I think I haven't shared till now that why we named this whole initiative Coordinated. I think obviously blockchains and all their coordination layers, but I personally learned about how blockchains are coordination mechanism. It's from Sreeram, because if you hear his talks back in 2022 to 23, he always mentioned that we want to build human coordination layer. Like he explained also pretty vividly, that stick to my head, and that is where the name comes in. I think welcome Shriram to the. I think sure. Thanks for doing.
No, wow, I'm so happy you call it coordinated, and awesome to be here. Thanks, Satyaki. Thanks, Parth. Really excited to do this. I've seen some of your episodes. It's awesome. Really excited for the amount of um, education and developer involvement you're bringing in here. Super excited. Thank you.
Awesome. I think let's start right away. I think we'll start a little bit about your early days in AI. So, one thing is now, especially in the last few months with agents kicking up and everything, we are seeing a lot of narratives being pumped up in CT. AI is the new thing, crypto is the like all this thing. And I think recently with developments of this LLM model, starting with GPT, then currently ending with DeepSeek, the latest innovation which came. I think you were in AI before all of this. I have seen many of your interviews and you have talked. I think you were in AI research and all before it was all cool and everything. So want to know about your period, like what brought you into AI then, and if you can share some of your journey from like your research background in AI and stuff out there.
Absolutely. My master's and PhD were in a area called information theory. Information theory is this field in by Claude Shannon, and it's the mathematical theory of storing, transmitting, processing information. If I have any specialty, it's really information theory. That was my PhD, and in my PhD, I was applying it to networks, wireless networks, peer-to-peer wireless networks. So you have a network of nodes, they want to communicate with each other. How do they maximize the rate at which they communicate information? How do they perform distributed compression? All these kinds of stuff. And after I finished my PhD, I went into a little bit of my PhD was basically curiosity search. I was working on something because it's curious. I mean, it triggers your curiosity, and so that's what I was doing. And at the end of the PhD, I solved some of the kind of old, what I thought were important problems in that space, and but had this whole existential thing of like, hey, what am I doing? What am I working on? Should find something that's more meaningful to do rather than just like for following my curiosity. And I happened upon a talk by Craig Venter, who's one of the founders of the Human Genome Project at Berkeley. And Craig Venter was talking about this 2012. Craig Venter was talking about creating new species of life. I'm like, what is going on? I'm trying to get people to download more data, and like the guy is talking about creating new species of life, and I'm like, okay, that's pretty bizarre. And I got very fascinated, even though my biology background was basically zero. Like I didn't know what is DNA or RNA at that time. I said, okay, this is the real, like, this is something that is so interesting and so crazy and so impactful. I want to just like work on this. And I have no background, no thing in it, but I said, okay, but that's what I'm going to do. So I became a postdoctoral scientist at Berkeley and Stanford, working on DNA sequencing and like algorithms, statistical learning, machine learning for DNA. That's what I did. So I did that thing. I started at the University of Washington, Seattle, working on statistical algorithms. So you get a lot of DNA. So what was happening was biology was going from like a very experimental science. You do an experiment, get some result, and then know whether your hypothesis is true or not, to information science. Like you just do one experiment and you get a terabyte of data. Like, oh, this gene's interacting with this gene, this cell is talking with that cell. You just collect a whole bunch of data. And then you just put it into a computer. And now like you have to build some kind of big data, machine learning, statistical learning, all these different names, the same thing, right? You just have data and you want to get analysis and insights. And so that's what I worked on. And I came here to the University of Washington. Basically, that was my job. My job was, I mean, I was an assistant professor, but one of the privileges of being a professor is you do whatever you want to do, whatever research area you want to work on, you work on that. So I worked on computational genomics, and as I was working on computational genomics, well, I was starting to build a very good program. One of the, just as an example, I wrote a paper with David Baker, who won last year's Nobel Prize in chemistry for actually using AI to understand protein folding. So the two people who won that prize are David Baker and Demis Hassabis. Demis Hassabis is founder of Google DeepMind, and started the whole, I would say, modern AI renaissance. So that's some like background. So the paper I wrote with him is on protein folding and AI and stuff like that. And so I had a very, very good program going on in computational genomics, trying to understand, analyze data. And one of my like pivotal point was in 2017, when I used to do like very complicated mathematical algorithms to try to analyze all these data, right? And one of my PhD students, his name is Ihan Jiang. Ihan came to me and he's like, Sreeram, we're doing all this mathematical stuff. You just do like deep learning and AI and apply it to this DNA sequencing stuff. And I didn't think it was a great idea because my collaborator on that project actually invented that nanopore, and he's a physicist who invented the nanopore. He also happens to have the strongest measurement of the gravitational constant, G, like, the GMM by R squared, that G, gravitational constant. He is the sharpest measurement of the gravitational constant. I'm like, I have the best physicist here. He knows how to do math. Like, we have done all this stuff. What is this deep learning thing? It's not going to work. You're wasting your time. He comes back in 2 weeks and he breaks our benchmark. And then I'm like, all he does is he takes this box, in these deep neural networks, which is just like this black box. You throw all the data in and it gives you a prediction. And it's better than all of these people kind of like building these models. And then I'm like, oh my God, that's it. This can't be happening. So initially I didn't believe him. I was like, he's getting wrong results. He's making up some data. Like, I don't know. And then I gave him a bunch of other problems, which looked similar. Okay, in a wireless cell phone. So I went from biology to like, other things I know have similar algorithms. And I said, I give you this data, like in a cell phone, you get some input data and then you have to remove the noise and then decode it. Can you go and do that? And then he does it. And then like the neural network's able to decode that. And then I'm like, okay, the only thing I know how to do is to do these kind of algorithms. I know this is black box, so just like throw the stuff in and it'll do it for you. I'm losing my job. So this is 2017. I already know I'm losing my job to AI. Then I'm like, oh my God, this is crazy. This can't be happening. I just thought I figured out a new area that I'm excited about, working on genomics and like going to use all these mathematical algorithms to solve it. Turns out, no, you just get beaten by a black box. And so that was a pretty like shocking insight for me at that time. So I started thinking about, okay, if this is happening, then what sets of problems is AI just going to solve? like this deep learning, deep neural networks, all this stuff. Just throw it, and then it'll solve what are those problems. And I have a thesis for like what those are, and it seems like it can solve pretty much all the problems where you have a way to know when you produce that result. If you have a way to know whether the result is good or not, then you can actually use that to train the model and just keep getting better. So if you have a way to evaluate the results, then you can just keep getting better. And so that was my heuristic. And then I started thinking, what is the one thing that AI can never break? And that's cryptography. And so I was like, okay, if we were to continue to use all these complex mathematical stuff, I said my PhD was in information theory, but I also have a master's in pure mathematics. So I was like, okay, if I have to use this stuff, I need to work on something that actually has some utility for my knowledge. If I can just throw it into a black box and it's going to solve it, it's other people can do that. So so one of the reasons, among a couple of other reasons which I talk about, one of them is, humans specialize. Humans are special because we coordinate, that Satyaki talked about at the beginning. And the second one, there are three reasons really why I got into blockchains. Number one was the coordination thesis, which is a very philosophical, ideological thesis. The second one is a very economic thesis. The economic thesis is big companies are rent-seeking all of us, right? Whether it's social networks, whether it is Google, like big companies, they just accumulate a lot of data, accumulate a network, and then they can actually charge a lot of fees across all the people, even though the network should really belong to the network. Instead of network belongs to Google or network belongs to Elon Musk or something. So as a second thesis is an economic thesis. And then the third one is a technical thesis. The technical thesis is in a world of AGI. So already I'm like 2017, I'm in my mind in the world of AGI because I got beaten and I'm like, okay, I don't know how long this game's gonna last. And so, okay, AGI is coming. Let's get ready. And the only thing that's stable relative to that is cryptography and now blockchains, which are just network manifestations of cryptography. And so I'm like, okay, that's perfect. So we can just work on the math and make sure that whole thing actually works. That's how I actually got into blockchains, is because I got displaced from my previous job, which was building algorithms, and AI took over my job. In fact, Ihan went out and started a company called IRA, which is in Silicon Valley with some of the wireless pioneers, which is using AI to improve wireless technology. So that's a whole other thing my student went off to do. But I chose the coordination thesis and got into blockchain for that time.
Yeah, I mean, from there now, it's been like a huge go for AI. And in terms of that, there is now like OpenAI, Claude, and various things. And also like crypto is full of AI for the last like couple of months and long time building from that. Just wanted to ask, is like AI truly decentralized?
Yeah. Just speaking a little bit to the progress over the last few years, I think it's been pretty insane. Just like even last 6 months has been like unbelievable, right? The set of things that we didn't know will be solved in 1 month, 6 months, 10 years got solved in like 1 month. It's pretty crazy. And so one of the things that we all underestimate in these kinds of systems is the exponential, which is that as AI becomes better, the time to produce the next level of AI becomes shorter because you can use those AIs to actually create the next AI, right? So it's some recursive self-improvement. And so this trend is ongoing and it will continue to go in that direction, which is more and more intelligence will be created. And so Parth's question is on what is the importance relevance of decentralized AI. And the way to think about it is one of the things I don't like is the word decentralized, even though I use it sometimes because it's a word in our area. Because no user really cares about like, oh, it's decentralized, right? It's not a value proposition by itself. It is an input to produce a certain output. The output is what we should focus on. So decentralization is an input. Let's say permissionlessness. So, it's permissionless. Anybody can come and use it. Anybody who pays a fee can use it. Censorship resistance is an output. So there are certain things which are outputs, and I think speaking to the output means a lot more than speaking to the inputs. So I think of like the output of all of crypto is coordination. Again, the show name. But coordination requires two things. Communication, like we're now communicating with each other. So in some sense, we are coordinating. But it also needs commitments, the ability to make and keep commitments, right? The ability to make and keep commitments is a superpower. So before I talk about AI, I'll just spend like 2 minutes on this specific thesis that coordination is equal to communication, that people come together, they need to talk to each other, but they need to be able to enter into binding contracts, binding agreements, binding commitments with each other, right? So let's say 3 of us come together and produce the show and say like, we're going to divide the profits equally. That's a commitment. That's an agreement but we don't have that agreement here, but I'm just saying that we might enter into an agreement like that. So that is an example of that's a coordination, right? The 3 of us could go our own way and do something which is not that interesting, but come together and do something which is more interesting together. But that commitment that, the value that is created will be shared in a certain way, that makes it possible for more coordination to happen. So crypto and blockchains are mechanisms to make and keep commitments. Internet is a mechanism to communicate, right? So I can talk to you because, we are on Riverside recording, right, which is a internet app. But crypto is a mechanism to make and keep commitments. And I think that is the new thing that crypto is creating, the ability to make and keep commitments. And so now, like, I'll rephrase your question, and then like the answer will become more evident. Instead of asking why and how we want AI to be decentralized, we can ask why and how should AI make commitments? And then like the whole perspective shifts. So you can see what sets of commitments intersection AI. Like so when you say crypto AI, in my mind, I'm reinterpreting that as AI and commitments. What commitments might go into it? Can I make a commitment that this AI is universally accessible at this rate? Okay, that's an example. That's a great commitment to make. Can I make a commitment that this AI, whoever contributed the data, they will get paid when the AI is used? That seems like a great commitment to make. Can I make a commitment that when this AI agent runs, it does what it says it does? It's another commitment. That seems like a pretty good one. Can the AI make a commitment back to me that it won't hurt me? Like it won't go and kill somebody for like solving some problem that I give to it? Can an AI agent make a commitment to a human being? In sci-fi, you have something like the Asimov's laws, which says, don't harm a human, all this stuff, right? So can an AI make a commitment to actually do that? Can we make a mutual commitment to the AI that, hey, if you follow these, and if you pay some taxes, we're going to let you have like all these properties, but if you violate your taxes, then you don't have these properties. Just like citizens of a country have like relationships with the country. Can we do that? Can we have a commitment that the human DAO, like all the humans together, have a say, a voice in how AI gets developed? These are all commitments. Commitments that AI can make to humans, humans can make to AIs. Humans can come together to make commitments to create AIs. Yeah, so there can be other kinds of commitments, like you create an AI model, and say that anybody can take and build new things on top of my model. But whenever that model gets used, they need to pay a portion of the value back to me. Can you make and enforce these commitments? This is the scope of what is the crypto AI project, is the ability for AI AI creators, AI developers, the whole economy to make commitments to each other. So that's why I say this, and people think it's crazy, but I think it's true. Crypto is the greatest upgrade to human civilization since the Constitution. Crypto is the greatest upgrade to human civilization since the Constitution. And I say that because Constitution is a commitment to all the individuals in that country, saying, hey, here is your right set of rights and responsibilities. And crypto actually makes it possible for you to make and keep much, much more general commitments in a much tighter way. So it is as big an upgrade as a constitution. So when, Satyaki mentioned my early thesis on this is humanities coordination engine, humanities coordination layer, this is what we mean by that. We mean that humans, we've coordinated, we've created great countries based on things like the constitution. And what more can we create if you had like much more expressive, much more powerful commitment technology? And so so rephrasing, rethinking from decentralized, it's open AI, but decentralized. It's this, but decentralized. I don't like it because it doesn't say anything that immediately I can use to actually process what the new things are that need to be built. But commitments is a very sharp phrasing.
Awesome. I think since we're talking about this AI and commitment thesis, I've heard you saying a lot amount of times that, okay, the smart contracts are actually not smart. They're rigid. And some amount of intelligence can be went in. Even I think when Uniswap was started, I think now we're in V4 with hooks and all, lots of things can be done, but it was a simple AMM model. I think you shared some insights. Okay, AMM models can also be AI driven and AI powered. So want to know, like, if you can share some more clarity out there, what do you actually mean by smart contracts and how all these DeFi mechanisms can be AI powered?
Okay, awesome. So I'll take one step back and then come back into this. So when you think about, I know there's a lot of buzz around AI agents, and I want to phrase the agents and like this intelligent smart contracts, intelligent DeFi together. So when you think about agents, you can think of what's an agent versus what is AI or an AI model or whatever. I think first thing, the definition is an AI agent is an AI model which can take actions. The ability to take actions is what differentiates an agent versus just a model, right? In a model, you can just run the model and then you get an output, right? You take an input and then you get an output. But in an agent, you have an input and then it takes a bunch of actions, go and call, if it's a physical robot, it'll go and like grab your coffee and give it to you or whatever. That would be an action. But it's a software. So the action is call other software, right? This is what is called tool calling. So you're calling other tools to actually run your own model. So when we think about the AI agents, so that's what an agent is, right? The agent is just a model with the additional ability to take actions. In software, that would be additional ability to make calls to other software. Usually these are APIs, so you're making API calls. That's what an agent is. So now when you think of agents, you can, I think of three categories of agents. The first category is personal agents. It's like, oh, I need to do something. It's helping me. It's an individual. It's helping me do something. And I think these are the ones where I don't think we should think a lot about verifiability and other stuff, because it's for me, and I can decide whether I need it to be verifiable or just run it myself, or I can find a friend to run it for me, or I can ask Amazon to run it for me. It's up to me, right, as individuals. So the next level, this is, I call these personal agents. And the next type is agents of the collective. Look, we've all come together and then we want to take some action, and then the agent is taking actions on behalf of this community. Then those agents need to be verifiable. Why? Because this is a perfect example. A simplest version of an agent of the collective is a smart contract, right? An AMM contract, which is a decentralized exchange, says anybody can come and put money into it, and then it'll trade according to this equation. Right? That's what it's saying. I put my money into it, and then anybody can trade relative to this equation. This is a beautiful, really nice, simple thing that can be built on top. But you can start agents of the collective when I can say, no, here is a complex AI model, and this model's code is stored in the blockchain. And whenever I put some money into it, it trades my money according to this model, which is pre-committed, pre-specified on the blockchain. Just like a smart contract gives you a feature to say, whenever I call that contract, this piece of code is what is being run. An AI agent connected to a contract or an agent of the collective will basically say, whenever you call this, whenever you put money into this, it trades money according to this specific model code, right? Like that's what it would say. Okay, so that's the second category of agents, are agents of the collective. I'll come into give a lot more examples. The third one is agents of themselves, right? So this is a crazy third possibility. This is, they're AI agents. They're not there for you or me or for the collective. They're up there for themselves. They're out there for their own personal gain. And that could be a third category. So it could be my agent, it could be our agent, it could be its own agent, right? Three different categories of agents. The third one, the first one, if it's personal, then you don't need autonomy. It doesn't need to do by itself. It doesn't need to be verifiable, because I know I'm running it. I don't have to prove to anybody that I ran it or anything like that. The second one is, if it belongs to the collective, then you need verifiability, because how is the group trusting it, right? So that's verifiability. Needs autonomy, but not that, not unlimited autonomy, because it's still listening to the DAO or some kind of collective is able to make those decisions. So that's number two, autonomy. Limited autonomy, but full verifiability is needed. The third one is agents of themselves, right? Like now you need full autonomy, full verifiability. It's just its own thing. It's like a new living thing. Will go and do whatever, like live and die on its own. Those agents need full autonomy and full verifiability. These are three types of agents. Satyaki and Parth, you guys may know that we are rebranding AVS from actively validated service, which means like any service that requires active validation, to autonomous verifiable services, right? Any service built on Eigenlayer or built using this, which has certain properties. So this is the same thing I was saying about decentralized earlier. Decentralization is the input, but the output is some kind of commitments that you get in crypto. In the same way, you're doing active validation, some group of nodes coming together and doing active validation. That's the input. What is the output? Is you get autonomy. So that a service is said to be autonomous if it doesn't rely on anyone, and anybody can come and keep the service going. And because you have staking, anybody can come, anybody has ETH. They can just lock the ETH and keep the service running. The service is autonomous, runs on its own. Second, a service is verifiable. Verifiable means run it and then like somebody else can verify it. And on Eigenlayer, we use verifiability for slashing, right? So somebody has put money and they're running it, and if it's wrong, you can slash the validators. So that is the two basic properties. In fact, in a distributed system, the first property is called liveness. The system is live. It just keeps running, autonomous. The second property, verifiability, is called safety. You run the system does what it says it does. So those are two properties that are needed. So we call these autonomous verifiable systems. So what we did is just mapped agents, and when do you need autonomy, when do you need verifiability in these agents. So that's the first aspect. Now, inside each of these like categories, you have personal agents, you have agents of the collective, you have agents of themselves or sovereign agents. And each of them is like really interesting to study. The first one is the least interesting for crypto because, you don't need all the verifiability and other stuff, right? But it is still useful. Like I can have a personal trading bot that runs on my computer and does trades for myself, right? And I don't need to show it to anybody else. I can just keep it for myself. So it's useful, but it's out of scope for what we are interested in at Eigenlayer. As our main selling point is autonomy and verifiability. Okay, the next one. So we go to agents of the collective. Actually, maybe let's go to the last one, which is much more crazy and interesting. Agents of themselves. So these AI agents that just live and die on their own. And I think people have like some toy ideas for like, oh, it's an autonomous agent. Right now, none of these agents are neither autonomous nor anything. Like they're all run by somebody in their server. You can take them down any day. So they don't qualify on like this, neither autonomy nor verifiability in our view. But if you had agents which are actually autonomous and verifiable, then suddenly they just have their own money, their own wallet, they can trade their own programs, they can interact with other stuff, and you suddenly have something very, very interesting, because it's almost like a living thing, because it has money, uses its money to spend on its like nodes to come and run and execute AI inference, whatever, and then get the results on chain. And then it needs to have money to pay them. And by using the outputs of that inference, it's actually able to go and trade and do some actions on chain and make money. And if it is making money, more money than it spends, then it stays alive. But if it's spending more money than it's earning, then it dies. So that's it. So that's the third one. Like the reason the third one's very interesting to me is it could very well be in like 10 years that a large portion of the world economy may be run by agents. Just not even personal agents or the agents of the collective, just fully autonomous, fully sovereign agents. Crazy thesis, but I can't see why it won't be true. So it's a disturbing but crazy thesis. Okay. So these AI agents can actually now start. So initially it looks like it's just like sitting on chain and doing something. That's what it looks like. But that's not what it is. Sitting on chain and doing stuff. And when you play these games, you have these superpowers that you could go pick up, right? So you're walking around and then you find a jetpack. Now you got a jetpack, you can fly. If you find a night vision goggles, now you can see in the night. These are like new sensors for either perception or actuators for actually doing actions. I think of this like kind of sovereign agent can acquire new superpowers. So a superpower could be, I want to read from the internet. So I'm an AI agent and I want to read from the internet. How do I do that? If I need to be autonomous and verifiable, that reading from the internet also better be autonomous and verifiable. Because somebody needs to do it. Who's doing it? As long as I have money, somebody should come and do it in a verifiable manner, because I don't want them poisoning my read from the internet. Imagine somebody gave you a night vision goggles and they don't show you what is actually in front of you, but they just show you some random stuff. Now you can die. You wear your night vision goggles and you're going on a hunt in the forest, and then it shows you like, oh, everything is okay, and then a bear bites you and then you're dead. And so if this thing that you're relying on for your sensors is not verifiable, then you might just die. So as an autonomous sovereign agent, you need to have your sensors. Oh, I want to read from the internet. That should be an AVS. Then you get a high grade of autonomy and verifiability in your sensor. Then I want to go and read. I want to know whether you're my counterparty. I'm an AI agent and you're a counterparty, and I want to know, like, you say that you're a good Uber driver. I need to know whether you're a good Uber driver. I need to use zk-TLS to verify that you're actually like who you are saying you are. You have your whatever authentication identity like that. It could be that I need to verify that you're logging in from Denver or India or wherever you're logging in from, right? So I need to know that. How do I know that as an AI agent who's stuck on chain? I use something like Witness AVS to actually know that, oh, you're actually in this location and you're doing this stuff. So each of this is a sensor for this new living thing, this AI life, which can now actually start seeing the real world. It can start seeing the internet. It can start seeing into your apps. Okay, so that's crazy. So now it's seeing. The next step is it starts doing. How do you do? I just put a bounty. I just say, oh, here is a bunch of money. Go and anybody can come and like now do actions. If you do the action and I can verify that you've done the action, I'm going to pay you out. Because, I'm an AI agent, I have verifiable read, I have verifiable sensors, and I have money, then I can do any action that is verifiable. That is crazy. Okay. So then you have this AI life, which is starting to not just be like something stuck on chain. It has no like actions in the real world. It says, go and create a billboard with my meme ID in like 10,000 cities and take a photo, verify it on Witness Infinity Watch, and bring it back. And I'm going to give you like a $10,000 bounty. And suddenly, you go around and you're spooked out that there's some AI life which has thrown a bounty for these people to do this. And then you start thinking, okay, as a person, I have like privacy. I can store my hardware wallet. I can lock it up in a ledger. I can do various things. Now, this AI agent can also do all those things by using a secure multi-party computation on Silence or a TE network on Automata or using fully homomorphic encryption on Inco or Phoenix. Okay, so now like it has privacy. Okay, so you can't like access all its information. Then it says, oh, I just don't want to do like this fuzzy AI inference. I also want to do rigid computation. Give me like a Cartesian coprocessor that I'm going to run as an AI agent and do computation to make my decisions. I need a database. So all this stuff. Each AVS is now used by these agents to actually build and compose. So each agent uses not just one AVS. Each AVS is like a superpower for the agent. I'd use all these things to build new and interesting things. So I'm telling this like a very anthropocentric, like, oh, it's like a human who's doing all this stuff. A very simple way to say this is if I want a verifiable agent, then all its dependencies need to be verifiable. Right? It's not just the model needs to be verifiable, but every software it is using also needs to be verifiable. That's what is called an AVS. It's a really simple point. But once you start seeing it from this lens, it's kind of like pretty crazy. What can happen is you can have like fully autonomous living things that can do all these things. So we talked a lot about number 3. I haven't still answered Satyaki's question on number 2, which is intelligent DeFi, but I'll come to it. And any questions on this or comments, thoughts?
Yeah, I think you quoted one thing, I think a couple of weeks back, that agents will be the number one consumer of the AVSs, basically. And I think that creates some amount of fuss. Okay, how can agents be using that AVSs and everything? Because I was reading the comments and other artists, okay, fine, this is Sreeram writing the agent hype just to create something. But I think this actually sums up, right? Because how I think currently 100 plus AVSs building on Eigenlayer. I think 50 plus of them are already live. I think one thing you are also, like you mentioned, I think that, okay, now I want to see cross AVS pollination and use case coming out of that. I think for a human, obviously, like it will be possible, but for an agent, let's say, which has its brain and which is learning on the way, there are all these AVSs, it will find its own way quicker than a human to use this AVS and come to a conclusion. So yeah, I think just like doubling down on that, your quote.
I'm just fundamental a little bit that a lot of people think it's because every project's doing it, right? Every project's like taking, oh, there's some AI agent, AI hype, let's just like pile on to the hype. And we've been like at AI crypto from like the very beginning. Like, for example, Ritual is AI, project Neeraj built. Neeraj was the first investor in Polychain, and we were discussing whether he comes work with us here at Eigen. I suggested no, go start a crypto AI thing, and which was Sentient, right? Is another major project. We just announced something today with Sentient. But Sentient was I helped the whole founding team come together because it was my PhD advisor and my friend Sandeep. So we've been thinking about this for way longer than people are just like. I sometimes pointed out that out of my top 8 research papers, I have a lot of research papers, but out of my top 8 research papers, 6 of them are in AI. Right? So it's not like we're learning this newly or anything like that. So, but the thing that for a lot of people, like why Eigenlayer is talking about AI, one very simple way to explain it: Eigenlayer is trust for off-chain computation. That's a simple way of explaining it. It's trust for off-chain computation. That's all that it is. What is the most interesting off-chain computation? AI. That's it. It's very simple. Our thesis and angle is very narrow and simple. We just provide trust. Now, it could very well be, Satyaki, next year, metaverse is the biggest thing, right? And we need to be on the metaverse. And then what is the big thing? Then the big computation that you need to do is gaming. And then we would be talking about Eigenlayer is the perfect place to provide trust for gaming. Why? Because it's fully expressive. You can express whatever you want. It's the same way how cloud works, right? So you look at AWS or Microsoft this year. Satya Nadella came out and said they're spending $80 billion this year on AI in Azure. $80 billion this year AI on Azure. If next year gaming is the biggest thing, they'll be spending $80 billion on gaming. Because why not? Because the cloud can support any computation. It's the same thing for us. We are just the autonomous, verifiable cloud. You can do any computation. Today, if it's AI, we will help AI build. Next year, if it's metaverse, we will help metaverse build. The year after, it is some other, in enterprise databases need to move on-chain. We will help enterprise databases move on-chain. Because Eigenlayer is fully expressive. We just provide trust in the most flexible possible manner. So we will write narrative after narrative after narrative because our core thing that we are doing is very narrow. We're just providing trust. So that needs to be understood. But specifically on AI is something that we've thought a lot more about. In gaming, I wouldn't speak with anywhere near the same confidence or authority, but this is something that we've thought a lot more about than most people writing some crypto AI hype. Awesome. And anything more before I switch to the second one, which is the agent of the collective?
No, I think you can talk about that.
Okay, amazing. So the other thing that I'm shocked about is how little people's imagination in what is blockchain is so limited. For example, Toli, who I like a lot, and Solana talks about there is no more 10x improvement left in blockchains. This comes from a very, 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 very narrow view of what is a blockchain. And it's a decentralized NASDAQ. Oh, you just need to trade the stock. You have a stock on some coin and you need to trade it. And you ask, what is the best way to do it? You come up with an architecture and then build it really well. But our thesis is not that. Our thesis is verifiable cloud, right? Which is anything that can be built on cloud. You want to make additional commitments, then you should build it on this new structure. So there's just one difference in point of view. And the reason I mentioned that is when you have a world with AI, everything in blockchain changes. Okay, so everything in not what happens to AI, just how blockchains are built and everything changes. I think the first one people are already getting an inkling of is you trade on a blockchain. You have an AI agent or something that, that runs for you that trades on a blockchain. That seems like a simple thing. You express your intent, and then it figures out what to do. because we can say, talk to it in English and then say, hey, figure out this, and then it goes. So yes, so that is number one. But that's not all. Then you start thinking more kind of like at a fundamental level. We just talked about, Satyaki asked me about intelligent DeFi, right? And intelligent DeFi is the idea that, there is an agent which is taking people's money, and then like any kind of DeFi protocol can be augmented with an AI layer, which does something more intelligent. What kinds of things? Like think of a Uniswap thing where you have to go and actively manage your liquidity position. Right? Say, I'm providing more liquidity in this price band or this price band. That needs to be adjusted. You can have an AI do it. And if the AI is already verified and autonomous and sitting on chain, then bam, you have a superpower. You can just like throw it in and then it does it. That's one super, super cool thing that you can do. Similarly, with lending protocols, you can have like automated like collateral management. It'll just monitor your thing and say, you're going under collateral. Let me just come and top up and refill or like buy some other coin. You can do like, and as you have, and maybe let me hedge my risk in a perp. And so you can do complex financial things that an AI can kind of like sit and do for you. Okay, that's the premise of intelligent DeFi, right? So you want intelligence concatenated into smart contracts. Then you can do like interesting things. Then you start thinking a little bit more, and then you see that one of the most important things you have in a blockchain is DAOs, right? So you have like some kind of governance layer, decentralized autonomous organizations, and this governance layer is usually like very messy, very complicated, and it's both more messy than like one person doing governance, and not necessarily more trustworthy, because DAOs get attacked and a majority can do whatever they want and screw the minority. So you have like all kinds of problems with DAOs. So what can you do? How do you deal with it? One way to deal with it is you have an AI, which you make some promises that any decision made by the DAO will comply by some principles. That AI will adjudicate whether you held to those principles or not. It's kind of like the same kind of thing we talked about with intersubjective commitments. This is commitments that are enforced by judicial, like AI as a judge. Right? It's an AI sitting in the middle of the DAO and saying, hey, you're taking action, but it's violating the minority rights, so you can't do it. That's a really powerful example. So this is one of the focus of the eigen-sentient collaboration. So we're very, very clear about that. And then to think about, it's not just DAOs, it's every token. Okay, so here is a problem with tokens. So when you create a token, you can either have like a fixed supply token, or a token where like, governance can create new tokens. The thing that the big benefit you get from governance can mint new tokens is you can encourage new contributors to come in to the whole ecosystem. And in the absence of which, it's very, 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 very difficult to continue to maintain an ecosystem. Actually, this is one of the root cause of the Ethereum problems. And nobody's kind of diagnosed this clearly. The reason is, who is incentivized to grow Ethereum? Who has that power? Okay, yeah, there's some EF and like whatever, but you should. So the way like most of the corporations work is you have like massive incentives to a leadership team, to an engineering team, whatever, to go and build to a business team, to go and grow the product, get the adoption. And if the value grows, like, so mostly they're funded with options. The way these options work is they say, if the value of the stock grows by like 2x, then you will get this bonus. But if it doesn't grow, then you don't get anything, right? Like this is exactly how, somebody should be running Ethereum, is saying, hey, please come and build and grow the value. I might not even build Eigenlayer. I might just go and say, like, let me grow Ethereum, and like, it would be great, instead of trying to find some other layer to build on top. Let's just build the thing that actually we all need and works for us. But there's no such thing. In fact, if I try to say that, people will say like, oh, Eigenlayer is trying to take over Ethereum and some BS like that. So you have this is the coordination. This is a coordination problem, right? So it's a fundamental coordination problem because you're saying that there's no incentive for anybody to actually take and drive this forward who's already not in the in circle, right? Like, and of course, the in circle people have already kind of like made money, so they're kind of more relaxed than anybody else. And that's so the reason I mentioned this problem is this is an example of a fundamental problem in all of blockchains is either you have a fixed supply token, in which case you can't incentivize new people to come and build, which might be okay for Bitcoin, which is committed to a principle of no innovation. Like, okay, we have the perfect new digital pet rock gold thing that we're all happy with. It's amazing. And then you don't need this. But for things that need growth, they need to be able to grow incentivize people to continue to like contribute and so on. And to do that, you need to have a mechanism to create new tokens. But if you did that, what would normally happen is the DAO will decide. What if the DAO decides and a majority of the DAO holders collude and give all the tokens, print more tokens and give it to themselves and dilute the minority? This has happened all the time, even in companies. But it's protected by courts. So you can raise an appeal to the court and say like, hey, I'm a minority shareholder. I don't know if you watch Social Network and Mark Zuckerberg dilutes his co-founder like this. And so there are stories like this at, Naval Ravikant had a famous lawsuit on opinions. So this is a big deal. And so this is called minority shareholder protection. There is no minority token holder protection. The DAO can screw the minority. But using an AI layer to protect, adjudicate this kind of like dispute is really, really, really powerful. It changes what can be done in a blockchain. Okay. So when you think about blockchains, you have like a user interface that changes because it's intents and apps become agents. You think about how smart contracts are structured. Smart contracts are absolutely going to have a layer of AI internally. Otherwise, they're not going to be intelligent. Then you think about how governance works. Absolutely going to have a layer of AI to adjudicate all your disputes. Every token will have a layer of AI protecting minority token holders. Okay. Every layer of blockchain is going to be imbued with AI, and we'll build this. So this is our part of our project is making sure all these functionalities, all these primitives get ready. So these primitives which enable, I can now do AI inference safely. I can plug it into a contract. Once you have this, our thesis, as you guys know, is open innovation. Like people have better ideas than we have. But by just laying out, giving them, empowering them with the tools, they're going to go and build all this stuff. So when somebody says there's no 10x left in blockchains, okay, I'll give you another example. How do you write smart contracts? Okay, so I was told when I joined back in when I joined in crypto back in 2017, I was told that the legal contracts are very difficult to read. We're going to make it amazing. You're going to just write smart contracts and you can read it, and it's binary. It's very really amazing. But fact of the matter, I'm a computer science professor. I run like a huge project in crypto. I can't read my smart contracts and be sure that they're correct. It's just what it is. I can read my legal contracts and be sure that they're correct. I can't read my smart contracts and be sure they're correct. This is a huge, huge, huge problem. This is why you have hacks, you have attacks, everything, because my contract is written in a language that a human cannot understand. So, I was thinking a lot about this. I have been thinking a lot about this problem. This is one of the fundamental problems of blockchains. So I looked at how Ethereum, because we always go back to Ethereum, how Ethereum solves this problem. Ethereum solves this problem. And the way to solve this problem is they say the Ethereum protocol is not written in code. The Ethereum protocol is written in pseudocode, in English. And 6 client teams have independently built it in code. Okay, so that's what's happening in the Ethereum protocol. Written the protocol, it's in English, semi code, which is easy to understand and process. And there are 6 client teams which are independently implemented them in code. Now, if those don't agree with each other, then we always go back to the English and then decide that that is the right.
Just to cut you short, sorry. By English, are you meaning the white paper, or is just a metaphor to explaining something?
No, it is almost it's almost the white paper. So the Ethereum's consensus protocol, what is called Gasper, there's a white paper, there is a set of specification. I think they're written in some pseudocode, Python level, like some very simple high level schema. But it's not the full code. It just tells you what the interface is, what the behavior should be. And then people write it in all these 6 languages. So Bitcoin is not like that. Bitcoin has a code called Bitcoin code. That is the Bitcoin code. Whereas Ethereum has an English specification. And then like 6 other teams built their client code, like Nethermind and others, like Prism and so on. That is Ethereum's solution. But Ethereum can do it because of 3 things. Number one, they first write their spec is in English. Second, they have client diversity. 6 clients implement the same code, and Ethereum can do it. And then number 3, if the clients don't agree, because Ethereum is an L1, it will fork around it. So these are the 3 superpowers. Things written in English, many implementations of that thing, and then if they disagree, then you fork. This is Ethereum's superpower. And I'm sitting here building a contract on Ethereum. I have none of this shit. Okay. I can't write my contract in English. Ethereum can write its protocol in English, but I don't have that power. Second, I mean, I can write 10 contracts, 10 Eigenlayer contracts, theoretically possible, and then cross-verify all of them on Ethereum. It's going to be really expensive. Not only in runtime, really expensive to develop. I need to have 10 engineering teams. Already we have too many people. And so that's going to be a problem. And then finally, I don't have the right to fork Ethereum. And makes sense. So what we're building in an AI world, you'll write the contract in English. And AI will synthesize that contract into many different implementations in the back end. And then they will all consensus with each other. If they're wrong, we will use eigenforking to fork around it. So this is coming up. So you're not going to write contracts in Solana or SolVM or Solidity or something. You're going to be writing contracts in English. And so this is our view. So now what went through the whole thing? Everything has changed. In an AI world, how blockchains work, blockchains in an AI world look nothing like blockchains of today. Everything is different. There's VM wars, right? The VM that has won is called English. Write it in English. So that's our thesis. So it is a crazy, I think when people are, the level of understanding of what is crypto AI, I think neither understands the superpowers crypto brings to AI, nor understands the superpowers AI brings to crypto. And so there is a huge journey ahead of us. So I think most people think there is way too much crypto AI hype. I think there is way too little crypto AI hype. This is, I think, massively societally transformational. And so, but well, we're there. We'll try our best.
Yeah, I think pretty much it. And I think we are short on time. So I think my final question would be around that a lot of people will be building on Eigen next week from Denver week, and a lot of new people coming in and building on AI specifically. So in short, I want you to explain why, what was your why behind verifiable AI?
When an AI agent is built not for yourself, but for a community to use, then it's much better for that AI agent to be verifiable, because now the actions of that agent are, it's one of the reasons. Okay, so if you think about, Eigenlayer has, 10 plus billion of like TVL, right? Why do we have that? It's because nobody needs to trust me or anybody in our team to actually put the money into it. It's written in code, it's written in smart contracts that are rigid, correct, just execute themselves. And it's the same thing with an AI agent. Like if I want to put my money into an AI agent, I better know who controls the private key. Firstly, I hate the idea that agents have private keys. If you have a private key, it's your private agent. Okay. It's not a verifiable agent should not have a private key, in my view. It should function just like a smart contract. So just like in a smart contract, if the inference happens, then the money will be moved. There is no, I don't need to trust anybody else. This is the only thing that scales. And just to kind of like get a sense of why I think the existing AI agent stuff doesn't scale, look at the total TVL of the AI agents. Not like the meme coin market cap of these AI agents, because those meme coins live on Solana or Base or something. But how much are people trusting these agents to give it real money? So if you see one of the things here, over time, you will see trust is very, very hard to build. This is one of the reasons why Ethereum has a lot of TVL and other chains don't, is because trust takes time to build. And people only give TVL to things that they trust, asymmetrically relative to anything else. And it's the same thing. If you want to build an agent, you want to attract TVL, build it verifiable.
Yeah, I think one last question, Sriram. I think as Parth mentioned, we are short on time. Just quick one thing. I think one thing we are all hearing a lot about, like Eigen's AI initiative. I think that's very apparent by all the communications which have been going and all the things which are going. And I'm sure there is something being built in-house. And I know that might come in the next few months. But yeah, I think if you can share some alpha about it, like what we can know, like what can we think, like what's going to come out of this initiative of Eigenlayer?
Yeah, well, our USP, unique selling point, is verifiable trust, right? It is not AI, it is not any of these stuff. So what we will be building a lot is on enabling, empowering other people to build things like AI inference, AI agents, all of this stuff. But how do we supply trust for it, right? Of course, the simple way is, you stake and then you get trust. But that's not the only thing. There is a lot of things beyond that. For example, when some group of nodes run AI inference and then like you want to bring that answer on chain, what if they were wrong? How do you verify it and slash them? Is there like, we have a slashing protocol going live, but that still doesn't tell you how to verify it. You have to write your own slashing contracts on chain. How are you going to verify AI and then are you going to write a AI fraud proof on EVM and things like that? It's very, very complicated. So what we will be building is these kinds of generic tools that enable people to build lots and lots of things on top of us. We don't want to be the team that's building, we built a new like virtuals competitor or something, right? That's not where we will be operating at. We supply trust, and we just want to uniformly increase the amount of trust in the crypto ecosystem.
Awesome. I think it's more than an hour, I think, but it's just 0.001% we got about picked your brain about AI, and I think you have a lot more to share. I think super thanks for doing this and giving us time, and obviously we'll host you again soon and talk about some other topics. Yeah.
Amazing. Thank you, Bharat. Thank you, Satyaki. I really enjoyed this, and keep doing the great work that you're doing. Thank you.
Awesome. Yeah. Thanks.
Bye.